Hi there. In this presentation we will discuss about estimation of fruit number in coffee trees by maturity level, based on color space weighting, using a new segmentation algorithm. Objectives: this study addresses two key questions. Can low-cost, user-friendly equipment adapt to crop conditions while ensuring image quality? Can a computer vision algorithm accurately count and classify coffee beans with over 80% accuracy using data from low-cost cameras? Methodology is based on the answer to these questions. The initial stage of this methodology consisted of compiling a database of coffee tree images captured using the author's custom image collection device. For segmenting coffee beans, the method based on candidate color channels was optimized, automating the channel analysis system and improving the weighting method for choosing each color channel. Histogram statistical analysis was conducted in 4 color spaces: RGB, hue, saturation, and value, HSV, CLAB, and YCBCR. Table 1 presents the first and third quartiles, along with the median values obtained after analyzing each color space channel. Table 2 presents the quartile values and median obtained from the analysis of each color space component for each class. We propose a method that leverages the geometry of ellipses, which closely approximate the shape of the coffee tree fruits. In this approach, the ellipse equation is parameterized based on metrics obtainable from the image data. Along the path between these points, the most extreme point is identified and determined by measuring the distance between coordinates when there is a change in the direction of the edge. Once the coordinates are known, a line is projected connecting these points to the ellipse's center. Using trigonometric ratios, the angle alpha is then calculated. For each set of coordinates, potential values of the angle alpha and the parameter are projected. Based on the ellipse equation, it becomes possible to project the ellipse corresponding to the analyzed arc. Angle values exceeding 160 degrees are disregarded as fruit segments. The angle alpha determines the opening of the arc detected at the edge. The coordinate system is rotated so that its edges align with those visible in the image. Each iteration involves rotates the ellipse by 20 degrees until the projected ellipse overlaps at least 70% with the edge pixels. Ellipse is projected only if it fits entirely within the original image coordinates. Ellipses extending into the negative quadrant or exceeding the image boundaries are discarded. In the initial validation stage, the algorithm's fruit counts were compared with manual counts for each class. Table 4 presents the accuracy, sensitivity, and F1 score values for each fruit class as well as for the total number of fruits detected. This table presents the comparison of precision, sensibility and F1 score parameters between the proposed method and others methods cited on the specialized bibliography of the area. This article introduces a novel 2D image processing algorithm designed for segmenting and counting fruits on coffee tree branches. The algorithm achieving an accuracy of 83% for the samples. The proposed system provides a non-invasive alternative that preserves tree integrity while automating the fruit counting task. The proposed algorithm proves to be an effective solution for accurately segmenting occluded fruit, a common challenge in crops like coffee, and is a reliable tool for this task, ensuring precise identification and quantification of cherries to facilitate timely harvest operations.